there are 4 things the entire machine learning industry must learn from self-driving cars. When it comes to deploying machine learning, we can learn from the self-driving car movement, especially how not to deploy. Welcome to the Dr. Data Show. This is Eric Siegel, and what it's going to take for self-driving to launch on a large scale is very much analogous to and inspirational for what it takes for any and all machine learning project in the enterprise to successfully deploy. Although typical machine learning projects are much, much smaller in scope than the whole self-driving movement. So this is an analogy that we learn from. And in particular, what self-driving as an industry has done wrong is very much the same kind of error that most machine learning projects face. As we've covered, most machine learning projects actually stall before deployment. The technology works, the analysis part, the modeling part may be sound, but there's not an overall enough of a enterprise-wise organizational project leadership process to ensure that after that modeling is done, that the model actually be deployed into the field and start making a difference and make changes to existing operations. We can very much see that what the self-driving industry is experiencing as kind of a stall to its purported trajectory is very much an analogy to the kinds of deployment woes that so many machine learning projects face in general. And in particular, there are 4 deployment requirements that apply to all machine learning projects that self-driving as an industry has gotten wrong. So in this episode, I'm going to cover those 4 deployment requirements. So just a bit of background about self-driving and broadly what's going on there, and then we'll bring it back to the general 4 requirements that apply both to self-driving and to machine learning projects. So you can see it's very much as a close analogy and a very interesting one. Self-driving is a fascinating area. It's so important that we eventually get to the automation of driving, that autonomous vehicles come to be on a massive scale, right? We fallible humans don't do nearly as good a job as what many of us believe computers ultimately will do driving cars. But we've got a long way to get there. And there was a whole bunch of buzz in the last about a decade ago and several years ago, and now it kind of comes up and goes down. But you know what? Self-driving cars are doomed to be this decade's jetpack. Where's my jetpack? They promised my jetpack, and they promised the self-driving cars. They're not here. They're going to save countless lives, but it's going to be some number of decades. And people in the industry of self-driving are very shy to admit that. Now, of course, it depends on how you define it, but I'm talking on some level of broad deployment in general, where self-driving cars really are very much accessible to most people and can be used under most conditions in most locations. And I'm talking about full autonomy, where you could be asleep in the back of the car. So what we see now, for example, with Tesla is very much nothing but driver assistance. Advanced driver assistance, incredibly impressive and potentially valuable driver assistance, but certainly not driving automation. There's some semantic games being played here, but I think we can get past all the baloney there and just say, hey, look, these things aren't driving themselves. You have to have your hands ready to grab the wheel at all seconds, that kind of thing. So we can see this as a cautionary tale about hyping. Self-driving involves machine learning, but it involves other technologies as well. So just talking about technology in general, this is one of the most publicly visible cautionary tales about overhype, about hype and overzealous promises and a really poor track record and expectation management. And we can say that the industry of self-driving has at least perceptively kind of slammed on the brakes. The Guardian put it this way. They said the driverless car revolution has stalled, right? That's a shame to the degree it could have gone faster, or that it's actually been slowed down. But in any case, expectations have been greatly overblown. So in the mid 2010s, the amount of investment and sort of fanatical hype blossomed, led in no small part by very grandiose tweets by Tesla CEO Elon Musk, and basically reached a fever pitch, one that's premature. Those very high expectations were followed by a conspicuous absence of genuinely autonomous vehicles, ones that are truly self-driven, that you could sleep in the back seat. So this led to a certain amount of disenchantment, as Overhype always does. Investment has greatly decreased by now in the early 2020s. So what went wrong? Well, under-planning is an understatement. It wasn't a matter of overselling the core technology, the machine learning modeling, for example, the ability for predictive models, how well they can identify pedestrians and stop signs in images. It wasn't so much about the core technical components. Rather, it's the underestimation of the deployment complexity, of the planning needed to manage the inevitable string of impediments that arise while what must be a slow incremental release of such kinds of vehicles into the world. Where, after all, we're talking about machine learning models and other technology autonomously navigating these big, heavy objects right through the midst of our crowded cities, right? This isn't just like a single robot roving through a field. This is going from 0 to 60, and if you push the button and all of a sudden all the cars are driving themselves, as far as basically robots living amongst us, and there's no precedent for that happening on any, and there's nothing comparable. It's a great desire, to the degree that indeed they're much safer on average than humans, and potentially orders of magnitude safer eventually. But the definition of safety, the measure of it, and the other kind of organizational and pragmatic restrictions to and social and psychological acceptance and societal and government and regulation and legal, it's got to be incremental. So one pundit calls these things self-driving bullets, right? So there's going to be a lot of back and forth. There's going to be a lot of trouble when they cause injuries or death. Of course, the context here is the incredible number of deaths occurring with human-driven cars every year. So more than any other machine learning project, this one is so large-scale, so important, and there's none that demands more of a shrewd deployment plan that's deliberate and incremental and doesn't promise unrealistic timelines. So here are 4 deployment requirements self-driving has gotten wrong, and they apply to any and all machine learning projects. So this is sort of an inspirational analogy. Let's assume for the moment that you, the listener, are not working directly on self-driving. It's interesting to all of us, but you're not working directly on it, but you want to actually get machine learning to help in your enterprise. Even for projects, that does not involve really moving parts, no robotics, right? It's still the same kind of requirements. So very briefly, just to list the 4, don't oversell the technical capability. Number 2, don't convey the false narrative that the only thing that matters is improvement of the core technology. Because it's not just the development of the core technology, the building of the rocket. It's the launch of the rocket, the deployment into the field, the change to existing operations. That's the big step, and that takes a lot more than just pure technical capability. Number 3, make sure that the plan and timeline is transparent. And number 4, the metrics, the measures of how well it works and how well you expect it to improve in deployment over the pre-existing method, in the case of self-driving cars, that'd be humans, those metrics must be transparent. So let me go over those for a little bit more detail, and then just talk a bit about machine learning projects in general that are not robotic typically, and that for the enterprise that learn from these missteps of the self-driving industry as a whole, and similar missteps that we take within the pure machine learning industry and across all kinds of deployments. Then we'll take a couple questions from listeners and wrap it up. So this is the main meat of the matter of this list of four deployment requirements. Self-driving's gotten wrong, but that it needs to get right, and so too does any machine learning project deployment. So the first one I said, don't oversell capability. So, in general, what happens with machine learning projects is there is a tendency to use the word accuracy and imply that the thing can predict with high confidence both positive and negative cases, which is generally not true. Most things cannot be predicted like a magic crystal ball, such as whether a customer is going to churn. And going further than that, misconception about how well it can do, the concept, of course, of artificial intelligence often comes up, and there's no example that more notorious within the self-driving context than the way Elon Musk talks about his cars, for example, saying that they are already semi-sentient, right? So whether something's sentient or has self-awareness or experiences feeling the way animals and people might, super subjective, but it goes. The implication is that goes hand in hand with general common sense reasoning, the way humans are intelligent, which is also a very subjective concept. But trying to ascribe that to a machine is super misleading and is nothing but an ill-gotten, extraordinary exaggeration. So let's cut that out. Supervised learning does a great job at optimizing for the particular task that you can measure well. How well does it detect when there's a traffic light in the picture, and whether the traffic light green or red, is there a pedestrian in the picture, whether this customer is going to churn for an enterprise deployment application, this kind of thing. So, and sort of going along with that, Elon Musk also said, we're going to push a button and all of these self-driving taxis will, quote unquote, awaken. So it's hyperbole. It's a lot more than hyperbole. It's sort of mythology, and it's not helpful. We got to just be plain and real. Let's get a little bit down to earth about exactly what the thing can do. And even if you get realistic about and tangible and concrete about exactly what the technology is meant to do, and let's say you are a machine learning expert, you're a data scientist. Now let's get to number 2, which is don't follow the false narrative that is not only about improving the core technology and the core capability of that technology in and of itself. And this is the misconception that even the experts tend to get wrong, in my opinion, as the main obstacle towards very sound predictive models the main obstacle towards them actually getting deployed. And our surveys and other surveys show that more often than not, they actually fail to get deployed, as sound as they may be. So the problem is that the project has to be conceived of as an organizational, operational change, right? We're basically, how do we use probabilities to do these massive operations, the core of our business, more effectively? And, machine learning and the models that it produces, those are probability calculators. So that makes it perhaps sound a bit mundane, but it's still quite profound and amazing what it does. But the point is that you have to conceive of the project as far as making change to the operations where there's a technical component. It's not simply a matter of if we get that technical component to to advance far enough, it's intrinsically valuable and it's going to solve the problem. No, the problem gets solved by way of the deployment, and the deployment doesn't happen just by making that model more advanced. The deployment happens by deploying it, by integrating it, by getting the green light and approval from all different kinds of lines of business managers, and then actually making it, incorporating it so that it actually makes changes to operations. And similarly, with self-driving, it's not only about getting a car that's literally autonomous, it's also about getting the world to accept it, getting it out there. You can't expect to just develop it and then put it on the road and expect it to work flawlessly. There's going to be flaws, and the question is, what level of flaw is acceptable? How low does it really have to be before the world accepts that? That's a sociological experiment. You can't, you don't know. It has to be incremental. There's a trial and error relationship between the self-driving industry and the world at large. Very much analogous to at an enterprise, we want to deploy a model to make changes to operations. Well, you better really socialize the heck out of it and make sure people are ramped up and understand what it is you're proposing to do. And then when you actually do it, there's still going to be iteration and people are going to see the change. That's, in a way, it may not be real until it's actually put out into the field. Number 3 out of the 4 deployment requirements self-driving has gotten wrong is that the plan and the timeline have not been transparent, and those have also been extremely overblown. Just so many false promises. We're going to have self-driving cars within the next 2 years, and they've been saying that for 15 years or something, depending on who you're quoting. But very, very rarely, in fact, I think I've only maybe seen it twice, do people actually within the self-driving industry admit, you know what, it's going to take a few decades. I think I've only seen that twice. That sounds much more realistic to me. If you asked me 10 years ago, I would have said 30 years. You ask me now, I'm still going to say 30 years. Of course, it's very hard to put the number on it, but that kind of, it being transparent about, come on, let's be realistic. Let's just call it what it is. I don't think overselling it and pushing it through, and raising funds and whatever it is by overpromising, ultimately is going to help anybody. And then last but not least, number 4, which is that the metrics must be transparent. So what exactly are we trying to improve? So in enterprise applications, people generally throw around the word accuracy. And granted, the word accuracy can be used sort of in an abstract way of just basically meaning how well does it perform. But in actuality, to be precise, accuracy just means how often is it correct. So how often does it classify something as positive versus negative, yes versus no, or whatever the task you're trying to do. And that is typically, and more often than not, the wrong measurement, the wrong measure. It's a red herring. What you want is something like lift or cost of false positive, false negatives. And the same problem applies for self-driving cars, which is there's no transparency. People say this is safe, it's sound, we're going to keep it down, we've driven this many miles. There's a real lack of concrete, complete transparency in the performance of autonomous vehicles, even tests where you've got a human driver at the ready to grab the steering wheel. How often does it make mistakes, and how often do you have to prevent it from making mistakes? I don't know, maybe the field's seeing this as antithetical to the right fundraising and to the right legislative moves, but one way or another, the world's going to need to know. So that transparency and clarity about what it is you're trying to optimize, exactly what, you're just talking about arithmetic, but we have to be precise about what that arithmetic it is. What are we measuring? What kinds of mistakes or errors for any kind of machine learning deployment project? So those are the 4. I'll just list them again. Don't oversell the capability. Don't follow the false narrative that it's only about that, improving that capability, the core technology. No, it's about change management. It's about the deployment. Number 3, be transparent about the plan and the timeline. And number 4, be transparent about the metrics. So just a couple words about sort of how this translates for more typical enterprise machine learning projects, right? Where self-driving is really just an analogy from that standpoint, because it's a much bigger thing. It's not just the deployment for one enterprise. This is the deployment across enterprise, across car manufacturers, ultimately across cities and countries. So it's at a much bigger scale than a typical enterprise project where you're only making changes to the operations within your enterprise. And with a typical enterprise machine learning project, it's not robotics, right? You're trying to improve something about, decisions on who gets approved for a credit card application and which transaction gets audited for fraud, who gets targeted for marketing, et cetera. These don't have quote unquote moving parts in the same way. So we're not looking at 30 years at all, but the same principles apply. And I should also say that what Tesla's doing is sort of the most aggressive as far as overpromising and putting it out there, right, where they have their very advanced and experimental driver assist under the misnomer of full self-driving, which it totally isn't. And they've put it out there, so anybody who's paid the $10,000 and passes a certain kind of test through their system can try it out on their car now, so it's still driver assistance. They are still required to be responsible for the car driving and be at the ready at the steering wheel and all that. But it is a very aggressive, bold move, couched by mismanagement of understanding of capabilities and expectations. Excuse me. So what they're doing is very much a bold move that could ultimately help forge the world closer towards actual autonomous vehicles. And what they're doing might work. So that's with that admission, I still would say, please don't do it the way Tesla's doing it. If it works, if their extremely aggressive and somewhat risky posture around all this actually forges through and plows through, and all of the kind of people criticizing it, as I guess I am clearly, are relatively small voices. The fact is Tesla's huge and powerful, extremely valuable company. So they may have that potential to kind of plow through and do things in such a disruptive way. But you don't have to. So be real at your enterprise. Be transparent and help ramp up the powers that be and the decision makers and the line of business managers as far as exactly what deployment's going to do and what kind of measures of performance and what metrics you expect it to potentially achieve and how you're going to measure success. So with that, let's before we wrap up, let's go to a couple very important questions that we have here from our listening audience.
Aren't self-driving cars now already working and on the road?
Aren't self-driving cars already working? Isn't it just a matter of time? Some of them are already out there. We've already got self-driving cars, right? What are you saying? It's not happening? Okay, well, yeah, I'm pretty much saying it's not happening. There's some extremely impressive steps taken, but I would claim that they are a lot more limited in the trajectory towards broad acceptance and deployment than they may cosmetically appear. So, for example, Waymo, which came out of Google, has full self-driving taxis in Phoenix, Arizona, and soon in San Francisco without a driver. And you can hail the taxi. It'll pick you up, and you're the only person in the car, and you're in the back seat, and it drives you to your destination, which is obviously a very monumental relatively early step in this trajectory. Quite amazing. The thing that there's no transparency about is just how often they need a human to come in another car to the rescue. And we see on YouTube that there's plenty of cases where that does happen, and it's kind of awkward and embarrassing and all this kind of stuff. So the question is, do we have a fleet of self-driving taxis and it's a limited area of Phoenix. And it's, that city and the climate there and the particular limited area was chosen so they could specialize. So the solution, it's not a general purpose solution. It has been crafted and tuned for that very specific region within Phoenix in particular. They have the potential to turn it off if there's a weather problem or some such. But what there's no transparency about is just how big of a fleet of humans kind of tailing them or sort of staying within the vicinity of a number of these self-driving cars ready to get them. So the question is, have they really got it scaling? Is this like a profitable self-driving taxi business? No, I very much doubt that. I would say that instead it's, a monumental step, and, it doesn't, there's sort of a man behind the curtains. Not literally, because it is autonomously driving from point A to B, and they have it unleashed. It's just that it has the potential to say, I can't handle the situation. I'm just going to wait for a human to come rescue me. That does have to happen periodically, and there needs to be a fleet of humans at the ready. And it's specialized, it's limited. So there's a big difference between that very impressive and important accomplishment and the broader sort of large-scale deployment of self-driving taxis. Let's go to the next question.
For machine learning projects that don't involve robots, isn't deployment much easier?
Yes, I started to talk about it a bit. For machine learning projects that don't involve robots, isn't deployment much easier? Yes. It is much, much easier. And I don't expect a typical enterprise machine learning project to require multiple decades by any means. However, the same principles apply. We have these requirements that include not overselling, not fixating only on the technology, planning for change management, making sure that plan and that deployment plan and timeline is transparent and clear, realistic, reasonable, and that the metrics are transparent and are divulged and planned and understood and bought in for. So again, the self-driving thing is inspirational in terms of what's needed, and is something of a cautionary tale, where we can take that fascinating, dramatically rich story that is the development and early inception of self-driving and recognize it as very much inspirational for how we think about any machine learning project.